Now in this problem, we have to find out the value of V, and we are again solving it by method 2. So in method 2, let us suppose that this block is moving towards right side with a distance of x1, and this pulley is attached directly with the block, and this block moves downward with x2, and this length is L1 initially, and this is L2. So I can say and this length is L3. Okay, so this is a single rope. This is a complete single rope, and the length of this rope L1 plus L2 plus L3 will remain constant. So by writing these equations carefully, we can see that the total length L1 plus L2 plus L3 will be equal to, now you have to write the equation carefully, that you can see that this distance is initially L3, and if this block moves a distance x1 towards the right side, then this length of the rope will decrease by x1, and hence the new length of the rope will remain L3 minus x1. Okay, so we have to write L3 minus x1 here, plus now this pulley is at rest, and this pulley is moving downwards, and obviously as this pulley is directly connected with the block, it will be moving downward by a distance x2 as same as that of the block. Now this length L1 will increase due to the downward movement of pulley. If this pulley moves down, this length increases. So the new length will be L1 plus x2. Now again this length L2. This length L2 will increase due to the downward movement of pulley. So the new length will be L2 plus x2. So L1, L2, L3, L1, L2, L3 will cancel out, and we can see that 2x2 will be equal to x1. So differentiating, we get, by differentiating with respect to time, we get 2v2 is equal to v1. Now v1 is given as 4, you can see, and v2 is given as v. So 2v is equal to 4, and v is equal to 4 upon 2. That is 2 meters per second. Okay, now this is the method 2 of solving the pulley problems. Now in next question, I'll demonstrate method 3 and method 4 for solving these pulley problems, and I'll be proposing those third and fourth method for solving the problems in exams, because those are very smallest methods out of these 4. So thank you. Now in this question, we are doing it with method 2, which I've discussed in previous problem. And now in this question, you can see the situation. We need to find out the value of V. So we are using the method 2, and by method 2, I can assume that this block is moving upward by an distance of x1. So due to the fact that this pulley, this one, is at rest, therefore this point and this pulley will move downward with the same distance x1. Now let's suppose this length of the rope is L1, and this length of the rope is L2, and let's suppose that this block is moving downward by a distance of x2, and it moves upward by a distance of x3. Now we know that due to movement of x2 and x3, the length of total length of this rope L1 plus L2 will remain the same, and we are using this fact that L1 plus L2 is equal to, now we can see that if only this pulley moves downward by a distance of x1, then this length L1 will decrease by x1, and the new length will be L1 minus x1. But if this block moves downward by a distance x2, then this length will increase by a distance x2. So we need to add up x2. Okay, plus now L2 and due to the downward movement of a pulley, L2 will decrease by x1. So we are subtracting x1, and due to the upward movement of block by x3, this L2 will also decrease. So minus x3. So cancelling out L1, L2, we get 2x1 plus x3 is equal to x2. Now differentiating with respect to time. So 2v1 plus v3 is equal to v2. Now substituting the values, v1 is 2 and v3 is v and v2 is 3 meters per second. So v will be equal to minus 1 meters per second. Okay, now let us solve this problem by the method 1, which we have discussed, relative method of pulleys. And in previous that method, we need to do some changes in this situation. I'm doing that. So in the first method, we are concerned about the relative movement of blocks with respect to pulley. So if this block is moving upward with 2 meters per second, then this pulley will move downward with 2 meters per second. And hence, with respect to pulley P, let's suppose this is pulley P. So with respect to pulley pulley P, this is with respect to sign. Okay, so don't be confused. With respect to pulley P, V relative, I'm writing the relative velocity of this block. This is A block. So its relative velocity with respect to pulley will be 3 minus 2. And the relative velocity of this block will be V plus 2. So this is 1 and this is equal to V plus 2, and V will be equal to minus 1. So we can verify our answer by method 1. But you can see that method 2 is a bit long than method 1. And I will be demonstrating these problems by 2 more methods which are even smaller than method 1. Okay, so let's move on to the next problem.